All right, so in ABC, it wants us to show that the mid-segment ED is parallel to BC. So let's go ahead and highlight both of those segments, okay? It wants us to show that this segment is parallel to this one. How can we show that two segments are parallel? Emma?
If they have the same slope.
Booyah! If they have the same slope. So all we need to do is find, okay, what's the slope of ED? And then what's the slope of BC, okay? And for slope, all you got to do is count the rise over the run. So for ED, it's super easy. You just count, okay, we go down 1, 2, 3 units, so that's -3. And then we go to the right 1 unit, so that's +1. So the slope for ED is going to be the rise over the run. So it's going to be -3 over +1. So my slope for ED, what's -3 divided by +1? -3, okay? Now we're going to do the exact same thing for the slope of BC, okay? So to go from B down to C, I'm going to count 1, 2, 3, 4, 5, 6 units. And since we moved down, it's going to be -6. And in order to move to C completely, we have to move to the right 2 units as well, so +2. So my slope of BC, my rise over my run, is going to be what? -6 over +2, which simplifies to -3. Do they have the same slope? Yeah. So we write, yes, they are parallel. Perfect. Yeah, so that was the first part of number 1, okay? The second part says, and we also need to show that ED is exactly half of BC. And to do that, we would need to use what formula? The distance formula, our favorites. Okay, so we have to find the distance between B and C. Okay? So the distance between B and C, well, let's find the coordinates. The coordinates of B are 3, what? 3, 4? And the coordinates of C are, what is that? Is it 5, -2? Yeah, okay. So we have both of our coordinates, okay? We need to label them x1 and y1, and then x2 and y2. I'll make B x1 and y1, and I'll make C x2 and y2. Does it matter which one you make which? No, you're going to get the same answer no matter how you do it, okay? So once we establish that these are our coordinates, that's what we're labeling them, let's write out the distance formula. Who has it memorized already? Go ahead, Giselle.
x1 plus x2 divided by 2, comma, y1 plus y2.
Nope. That's the midpoint formula. What's the distance formula, Savannah? It's plus, peeps, okay? Think about it, okay? One way I like to think about it, we're finding the distance between each of the coordinates and squaring it, and then adding it between the distance of each of the other coordinates and squaring it. In other words, 1, 2, 3, 4, 5, 6 squared, 1, 2 squared. Watch, we're going to get 6 squared and we're going to get 2 squared somewhere, okay? Let's check it out. Okay. So we're going to do x2 minus x1. My x2 was 5, agreed? So this is the square root of 5 minus 3, and then we're going to square it. Plus, what's y2? Negative 2 minus 4, and then we're going to square it. You guys with me? All I did there was I just plugged in the values that I assigned. Are we cool so far? Okay. What's 5 minus 3?
2.
What's negative 2 minus 4?
-6.
Negative 6 squared. Did I not say we were going to get 2 squared and 6 squared? Ah. Okay. So now we've got the square root. What's 2 squared?
4.
And 6 squared?
36.
4 and 36 give us the square root of 40. Okay, now, is there a perfect square in 40 that you notice that we can pull out? Which one? 4. Very good. So let's break this down into the square root of 4 times the square root of 10. And what do you guys know is the square root of 4?
2.
2. So this is just 2 times the square root of 10. Does the square root of 10 break down any more?
Yeah.
It kind of does. You can do the square root of 2 times the square root of 5, right? But are either of those perfect squares? No, so don't keep working, okay? Only if you can pull out a perfect square. So like 4, 9, 16, 36, 25, any of those. If you can pull out any of those, then keep simplifying. Otherwise, just leave it the way that it is, okay? All right. So that's the answer, okay? But we only found one of the segments. What other segment do we need to find?
ED.
ED, okay? So we need to find the distance of ED. Yep.
What about breaking down? This is number 2.
So we don't break it down because 5 or 2, you can only break it down into 2 times 5. Neither of those are perfect squares.
Oh.
So only break it down if you can pull out a perfect square. Okay? All right.
We're still number 1.
We're still on number 1.
Wait, my work looks so pretty right now.
Okay. So ED, okay? Let's find the coordinates. What are the coordinates of E? I think it's like 1, 4. And then what's the coordinates of D? 2, 1. Okay. So again, assign them values. Let's make this x1, y1, x2, and y2. You should have the formula memorized. So it's going to be the square root. Actually, let me move this over. Yeah. It's going to be the square root. Oops. And it's x2 minus x1. So we're going to get 2 minus 1 squared. And then it's y plus y2 minus y1. So it's going to be 1 minus 4 squared. Now, remember, let's just double check. When we're counting the distance for ED, right? From D to E, there's 1. So we should have 1 squared. And we should have, there's 3 units up. So we should have 3 squared somewhere in there. We should have 1 squared and we should have 3 squared. Okay? So let's check it out. 2 minus 1 is going to just give us 1. So we're going to get the square root of 1 squared plus negative 3 squared. Did we get 1 squared and we get 3 squared? Sure did. Even though it's negative, it's going to turn into a positive, okay? So this is the square root of 1, because 1 squared is just 1, plus, what's 3 squared? 9. So this is the square root of 10. Oh. Check that out. Do you notice anything? It's exactly half the other one. If you don't get half, guess what? You messed up somewhere, okay?
Wait, I kept going and I did 2 or 5. Like, you know,
Don't keep going, okay? You want to keep going, right? But is 2 a perfect square?
No.
Do you know what the square root of 2 is? No. Do you know what the square root of 5 is? No, so you don't break it down anymore, okay? Unless you can pull out a perfect square, okay? All right, so now watch what happens. We were told, okay, prove that ED is exactly 1/2 BC. Let's just plug in what we found. So ED equals, ED equals 1/2 BC, right? ED we found was what? Square root of 10. So does the square root of 10 equal 1/2? And what was BC? 2 times the square root of 10. Are those equal to each other?
No. Wait.
What's 1/2 of 2?
1.
So the square root of 10 equals, this 2 will cancel with this 2, the square root of 10. And guys, when we're talking about mid-segments, this will always work. But if I don't see your work with the distance formula on it and you just magically appear with the square root of 7 and 2 times the square root of 7, I'm not giving you credit, okay? You need to walk me through the distance formula. Okay, and then the last thing, it says find the coordinates of the endpoints of the mid-segment EF, which is opposite AC. Okay? So opposite AC, so F needs to lie on which side? BC, excellent. So it's going to be somewhere along here. How do we find the midpoint of BC? This is where Giselle's formula comes into play. It would be add the x values, divide by 2, add the y values, divide by 2. So it's going to be 3 plus 5 over 2 and 4 plus negative 2 over 2. So F is going to be 3 plus 5 over 2 and negative, what did I say? Or 4 plus negative 2 over 2. 3 plus 5 over 2 is going to give us 8 over 2. 4 plus negative 2 over 2 is going to give us positive 2 over 2. And this will give us 4 comma 1. When we put that in there, it should line up with the midpoint of the side. And that looks about to be the midpoint, right? And we label that point F. So those of you that forgot everything about 6.4 before the break, okay, here is all of it in one question.
It's gonna be the test. This question.
Of course this is going to
No,
be
I
on your
mean
test.
This specific question.
Oh, yeah.
This question.
Is it just
Oh,
gonna
this
be
specific question? No.
Why would this?
By drawing an obtuse scalene triangle and then finding the largest angle, the largest side, and marking them in red. So first, go ahead, take out any kind of marker, actually preferably black, and draw an obtuse scalene triangle. So remember, what does obtuse mean?
It's
an angle bigger than that?
There's one angle bigger than 90. And what does scalene mean?
No sides are equal.
No sides are equal. So just draw one really large angle and draw all your sides. Okay. Find the largest angle in your triangle. And then find the longest side and mark them in red. So mine are going to be this one and this one.
Wait, can you repeat what you said? That
Mark the longest angle and the longest side in red. Do you see how clearly in obtuse triangle, the obtuse angle is your largest angle and your longest side is going to be this one, whichever one is opposite your largest angle.
Like a flat one?
Correct.
Are they always going to be opposite each other?
Okay, now in blue, okay, what you want to do is you want to find the smallest angle. Now, mine are pretty similar, but I would say this one's smaller. So just eyeball it. Whichever one looks to be smaller, mark it in blue, and then draw a line over in blue the smallest side. And you'll notice something very peculiar. The longest side will always be opposite the largest angle. And the longest or the shortest side will always be opposite the shortest angle. Okay? Write that down. Longest side will, how often? Always
Ooh, that's gonna be like
be opposite the largest angle. And then repeat the exact same sentence, but for smallest. So the smallest side will always be opposite the smallest angle. Okay? So, what this theorem says, if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. Okay? So, what we're going to do is, since we know that two of the sides have lengths that are given, one is 12 and one is 10, we're going to compare the angles that are opposite those sides. So, in one color, highlight AB, and then highlight the angle that's opposite AB, which would be C. And then using another color, highlight AC, and then highlight the angle that's opposite AC, which would be angle B. Which one of those two angles needs to be larger? Jaden?
C.
C, very good. Why?
Because side AB is longer.
Very good. The side opposite that angle is bigger. So if AB is bigger than AC, then we know that angle C, the measure of angle C, needs to be bigger than the measure of angle B. Now, if you think about that, like, logically, right? When you make an angle bigger, aren't you kind of like separating the two lines even further? Like you're making the angle wider. Wouldn't the opposite side then eventually grow? Okay? So the wider you make your angle, the longer that side that's opposite it, it's going to be. Because if you keep moving like this line further this way, aren't we making AC a lot bigger? Okay? So the bigger you make that angle, the bigger that side opposite it is going to be. Questions so far? Okay. It also works in reverse. Okay? So if you have a bigger angle, then the side opposite that angle also needs to be bigger. So if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So in this example, it is definitely not drawn to scale. So please don't take that and run with it, okay? But which of the two angles is larger? C. So then if we're comparing AB and AC, which one needs to be larger? I'm sorry, and CB. If C is the bigger angle, right? You guys said that the measure of angle C is bigger than the measure of angle A, right? Which side needs to be bigger? AB. So AB needs to be bigger than what? CB. Okay? The side opposite the angle that's larger needs to be bigger. Mariana?
Would the smaller angle that corresponds with the smaller side always be the base?
No. Good question, though.
Here, isn't it the biggest one?
Um,
It's the most straightest one.
but we don't know what this
Oh,
side
yeah.
is. Do you know what I mean?
Yeah,
I don't get the red part.
The red part. The triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. And then highlight, do whatever you need. The two smallest sides need to be bigger than the largest side. The sum of the lengths of any two sides of a triangle needs to be greater than the length of the third side. If that's not true, you can't even have a triangle, okay? Now, let's think about that visually, right? Let's say we had a side that was 4 units. Oops. I'm going to draw it over here on the left. Let's say we had a side that was 4 units, a side that was 10 units, and a side that was 20 units. Could these 3 sides ever add together to give you a triangle?
No.
No, because they're always going to fall short of the side that's really large, right? So adding 2 sides together, no matter which sides they are, they can never be greater than the third side. They always have to be greater than the third side. So adding 4 and 10, what do you get?
14.
14. Is that bigger than 20?
No.
No, so you can't have a triangle, right? But let's say you had 4, 10, and 12. Could you have a triangle here?
Yeah.
Yes, because the 4, 10, and 12, you add 4 and 10 together, those are the two smallest sides, you get 14. Is that bigger than 12?
Yeah.
Sure is, okay? So as long as the two smallest sides added together are bigger than your biggest side, you're good to go. Jaden, what's up? Okay, so in our example, it says BC added with AC needs to be bigger than what? AB. Okay? AB added with AC needs to be bigger than what? CB or BC. And then AB plus BC needs to be bigger than AC. Okay? So all of those need to be true. My check that I always use is pick the two smallest ones and make sure that they're larger than the biggest one. Okay? Okay. All right. Example 1. Name the largest angle and the smallest angle. Well, let's name the largest first. Largest is angle C. Why? Because 10's the biggest side, right? Which angle is opposite 10? Angle C. Do you guys see that? Okay, what is the smallest angle?
A.
B.
Angle B.
Wait, how is C 10?
Probably is opposite from this.
Okay, so do you agree that 10 is the biggest side, right? So if it's the biggest side, the angle needs to be the biggest as well. So C has to be the biggest. You agree that 6 is the smallest side of all the 3, right? What angle is opposite this side?
B.
B, right?
Oh,
So angle B is the smallest. Mm-hmm.
Is it literally like this?
Some of them are. No. Okay. Example 1. Name the longest and the shortest side, but they're missing one piece of information. They didn't give you angle T. Jaden?
The longest side is side IT.
Okay.
Is that LT?
It's an I. So Jaden said the longest side
Because it looks like an L. That's not
is IT. And I agree with him. Why is IT the longest side? Do you know?
Opposite is the biggest angle.
Very good. But we don't know the angle T. Yep.
But we know it's an opposite triangle and that's the largest because it's bigger than 90.
Very good. If you ever have an angle that's bigger than 90 or equal to 90, no other angle can be bigger or equal to 90. Okay? If it's obtuse, only one angle is obtuse. Since 105 is there, it has to be the longest side. Now, how can we figure out, because we do have to compare the 46 with the missing angle. How could we compare those? Giselle?
Add 46 and 105 and then subtract it from 180.
Bingo. You have to take 180 and then subtract 46, subtract 105, and someone who's better at doing this than I am, what did you guys get? 29? Okay. So what would the shortest side be? It's not 29. Carlos? IJ. Why? Yeah, 29 is the smallest angle. And what's the side opposite that smallest angle? IJ.
I think we should have a test just like this.
I think that would be too easy.
I think I would get my first A. I think this is what midterms look like.
Hard to do without drawing a picture. So go ahead and draw a nice right triangle. Oops, that was a terrible line. And which angle, or how do I need to label my letters? A, B, C? No.
Oh.
C needs to be where? Here. A and B can be either one, but C has to be right here. Okay? The measure of angle C compared to the measure of angle A. Are they greater than, less than, or equal to?
This angle C is greater than.
Angle C is greater than. Why?
It's the biggest.
Since it's 90, the other two are equal.
Yeah, because the biggest A can be is like 49, right? That would make B 1 degrees. I'm sorry, not 49, 89, right? And then B would have to be 1 degrees. Because together they have to add up to 180, right? And you can't have a measure of an angle that's 0, okay? So this has to be the biggest angle. Anytime you have a 90-degree angle or an obtuse angle in there, that is always the biggest angle, okay? So angle C must be bigger than angle A. Angle C, how does it compare to angle A plus angle B? Gabby?
It would be equal.
Why?
Because angle A plus angle B is equal 90 and C is 90.
Very good. In a right triangle, the two acute angles are complementary. Do you guys remember that? So if these two add up to 90, and this one's already 90, what's their relationship?
They're equal.
They're the same, okay? Now, how does AC compare to AB? Jaden?
It's less than.
It's less than. Why?
Because the opposite angle of angle C, which is 90 degrees, is AB, and then angle C is the greatest, is like the greatest angle measurement. So we know that B and A are acute, so it means it's smaller than 90, so it means AC, which is across from angle B, is less than.
Excellent, okay? AB is the longest side because angle C is the largest angle. Not too bad?
Yeah.
Okay, let's go on. Example 3. The lengths of two sides of a triangle are 8 and 13. Then the length of the third side must be greater than what, but less than what? Okay? All right. This is how we do these kinds of problems. Okay? The first way I want you to set it up is think that 8 is the shortest side. Okay? So if 8 is the shortest side, then 8 plus 13, right, needs to be greater than the missing side, which is C. Okay? 8 plus 13 needs to be bigger than the missing side, which is 13. And what is 8 plus 13?
Oh, 26 or something. I did the math.
21. Okay? So C needs to be smaller than 21. Okay? So the length of the third side must be greater than we don't know, but we do know it needs to be less than 21. Because if it was bigger than 21, then we would have one side that's bigger than the other two sides, right? The other way you have to spin it is say, okay, 13 needs to be the largest side.
But wouldn't that just be?
Then what's 21?
Okay? What?
Then what's 21?
Watch, I'm going to show you, okay? So if 13 is the largest side, then 13 needs to be smaller than 8 plus C.
Oh,
Okay? Because remember, if 13 is the biggest, then the two smaller sides need to be bigger than that side, right?
What? So
Very good. Okay? So now you're going to subtract 8 from both sides, and you're going to get, okay, 5 needs to be less than C. So it needs to be greater than 5, but it also needs to be less than 21.
So 21 is our largest.
21 is our largest, and 5 is our smallest.
So then this information is not.
What do you mean?
Like we're always. How is that sign? That's basically a less sign guy or what? Oh wait.
Like we're always gonna.
Okay, let's do one more and see if it clicks, okay?
What do you guys not understand?
So a triangle has one side, okay? So take your smallest one and make it the smallest. So we're going to make 9 the smallest. So 9 plus 14 must be less than, or I'm sorry, must be greater than what? C, our last side. Always put it as C. Think that you have side A, you have side B, you're finding side C, okay? So what is 9 plus 14?
23.
23.
Good job.
Redemption. 23 is bigger than your smallest, than your third side. So 23 is the maximum, okay? Now, spin it and say, okay, now 14 is my biggest side. If 14 is your biggest side, then 9 plus the other small side needs to be bigger than 14.
Oh, which is 5.
So now we just subtract 9 from both sides, and we get that C needs to be bigger than 5. So C needs to lie somewhere between what two values? So 5 needs to be smaller than C, and C needs to be smaller than 23.
So you basically
Yep.
just add and subtract. Not even kinds of problems. You always have to.
Triangle to have sides with the lengths as indicated, okay? Watch. So all you have to do is pick out the two smallest, which would, in our first example, be what? 6 and 8. So 6 plus 8 needs to be bigger than 10. Is 6 plus 8 bigger than 10? Yes. 14 is bigger than 10. So yes, we have a triangle. Okay? Next one. We take 3 and 4, we add them together, and they need to be bigger than 8. So we do 3 plus 4, and that needs to be bigger than 8. 3 plus 4 is just 7. Is 7 bigger than 8? No, so not a triangle.
Oh my god, this is so easy.
Yeah, fraction, Tom. Yeah, I mean.
Of course. Okay, next one. We have 2.5 and 4.1 and 5. Which one's the two smallest? So we add 2.5 plus 4.1, and we compare it to 5. It needs to be bigger than 5.0, and we get that this is 6.6, right? Is that bigger than 5.0?
Yeah.
So we have a triangle.
Can you do an example with fraction? Because you're gonna pull that one.
Please no fractions.
There will be fraction questions on your homework. Okay? 4, 6, and 2. Add the two smallest.
4 and 2.
So we have 2 and 4, so we're going to put 2 plus 4 and compare it to 6. Is 6 bigger than 6? No, so it's not a triangle. 6 is not bigger than 6. 6 is equal to 6.
Wait, but how come when you do it here, like you did the 9 plus C and got 14 still? Like 5 plus 9 is like 14.
Yeah, because you're saying that has to be bigger than 5. So C cannot be bigger. Okay. And then the last one. What are my two smallest sides? 5 and either of the 6s. So 5 plus 6 needs to be bigger than 6. Do we have a triangle here? 11 is bigger than 6. Check marked. Check marked.
So if it's equal, it's not.
If it's equal, it's not a triangle. If it's bigger, it's a triangle.
Wait, why can't it be
Yeah, why
not
can't
a
it
triangle
be
if it's
equal?
equal?
Okay, let's think about it. Let's say you have, I love this question actually. Let's say you have a segment that's 2 units, another segment that's 4, and one segment that's 6. Do you see how the only way you could reach from one endpoint to the other is if you line them straight up along this line?
Yeah.
So you wouldn't get a triangle.
What if it was an equilateral?
Okay? So I'm saying like you have one side that's 2, one side that's 4, one side that's 6. Right? In order to have a triangle, all 3 of them need to meet up, right?
Yeah.
They need to,
Put the 4 like in the middle.
What?
Like it made it like if you make it a triangle like
but like no matter how we organize it, the 4 and the 2, it's going to end up short. It's not going to reach this endpoint unless you line it up where they're next to each other and the other one's right here. But that's not even a triangle. That's just a line.
Yeah, sorry.
Okay? So the 2 smallest sides need to be bigger than the third side. They can't be the same. Okay? Yes?
If it was an equilateral and it was like 4, 4, 4, you would still add, because the smallest and
Yep.
biggest is 4.
So you would just pick 2 of the 4s, add them together, and it would have to be bigger than the third one. All right. Get muddy. What was the hardest part of the lesson?